Hey guys, so welcome back. In this video, we'll be trying to solve the problem of the day on Geeks for Geeks of 16th November, that is longest common increasing subsequence. Alright, so you'll be given two arrays A and B. You have to find the length of the longest common increasing subsequence. Okay, so if you see this particular case, we can't sort the array, we have to keep the original order. Okay, if you see here, you have 3 and 9, which is the longest increasing subsequence. You have to return its length. So here the length is 2, right? So just output 2 as the answer. If you see this particular case, you have 1 and 4, right? You also have 1 and 3. So both of this, uh, both of these subsequences are there in both of the arrays. So the answer should still be 2, all right? Because the length is 2. Now let's see as to how we can solve it, okay? So let's say that we have two arrays like this. All right, we have A and B. Now I'll be explaining with a basic example as to how it works. Okay, so the first thing is we have to use diagonal programming to solve this. Okay, of course you can use an n-square approach if you wanted, but again we're looking for efficiency as well. All right, so basically our DP will basically be storing the biggest length of the sequence we found up till a particular element. Okay, so this will be the length of B initially. So initially everything will be equal to 0. Okay, because we didn't find like anything as of now. Okay, now we'll be having an I pointer going through A, right, and a J pointer going through B. Okay, so I pointer is initially over here. We'll check if I and J is same. It is not same, right? So now we'll move the I pointer forward. I mean the J pointer forward. Now 3 and 3 it matches, right? So now what can we do? We found at least one sequence, right, which has the same element. So what can we do is we can erase this right here and we can change this to 1. Okay, because now we have an array of length 1, which can be a part of our longest increasing sequence. Okay, so now the I pointer will move forward. Okay, so we can erase this and this. So now the I pointer will move forward to 9. Okay, then the J pointer again starts from 5, it's not same, then goes to 3, not same again, then it goes to 8, not same, then it goes to 9. Okay, here 9 and 9, it matches, right? So what can we do? We can just change it, right? We can just change the value of our DP array, where it is 0, we'll just be changing it to 2, right? Because initially we had 1, like we'll also be having a variable to store the maximum length of the subsequence we have as of now. So now initially it was 1, now we saw that 9 and 9 matches again, so we can increase that by 1. So now we have 2, right? And we put 2 inside our DP. Now we keep on doing this for like every single approach. This is not O of n square, or rather I should say it's O of n into m. Alright, so that's how we solve this problem. Let's see as to how we can code this out. Okay, so let's try and code this out. First thing is you'll be having n, which will be equal to the length of A. Alright, let's put this equal to. Alright, then you'll be having m, which will be the length of B. Okay, now after this, you have to initialize our DP array, which will just basically be 0 into the length of m, if you remember. Alright, okay, now for I in range, n, right? We initialize our variable, as I said, max length will be equal to 0. Now, for j in range, we only want to go till m here, right? Because the next array we're going to search for. Set current val is basically the value you have right now to be dp of j. Okay. Now, after this, if I should say a of I is equal to b of j, if this case works, then just set dp of j equal to the max of current val. Let's correct this. Current val or max length plus 1. Okay. Now else if a of j is lower than, I'm sorry, b of j is lower than a of I. If the element we found is smaller, right, then we just update the max length what we have. So max length will be equal to the max of max length and current value. All right, that's basically it. So now what can we do? We can just return the max of DP. All right. Now this we can do only if we have possible values inside the DP. So we can decide if DP is just to output 0. Okay, now this should work. Let's see. It should be N over here. Very good, works. Let's submit. All right, that's how you solve this problem. If you have any doubts, do let me know down below. And that's it for this video. See you in the next one. Goodbye.